Lesson 39 deals with quadratic functions in factored form. Basically, a quadratic function, we know that the exponent is going to be squared there, creating that parabola, whether in curve up, curve down. Basically, what's happening here is you're not going to have that trinomial, and you're going to go ahead and factor it down, much like you did in Unit 7 when you took a trinomial down into two binomials. From this, basically what we are finding is our x-intercepts, where it crosses the x-axis when we factor that down. The factoring process is called the zero product property, and that's what we would use to find these x-intercepts. So we don't necessarily have to graph like we did in Lesson 38 to find an x-intercept. Remember when we did it in Lesson 38, to graph it, that's basically an estimate. In the zero product property, you're getting that true value. And then also it talked about the y-intercept, and that would be where it crosses the y-axis, and that can be found much like you have in linear functions here. So we'll give you a couple examples here and see how this all works out in factored form. So our first example in A, we're going to use our zero product property. Notice the A value is 1. When A is 1, this is kind of what we did in Unit 7. We went ahead and filled our x's in there, and then what we wanted to pay attention to is this right here. We saw plus, minus. We remember that plus, minus is plus, minus. The next thing that we look at is, alright, what has a product of C and that would have a sum of B? So what times what gives me 35? Well, we know that's 7 and 5. And then we need to figure out, all right, using 7, 5, how are we going to get that sum of B? Well, we would have to have a positive 7 and a negative 5. We'd go ahead and set this equal to 0 using the zero product property. And basically what you do is you take each binomial and set it equal to 0. So you'd have x plus 7 equals 0, and you would have x minus 5 equals 0. Basically what we're doing here is when we use this zero product property, we are finding the x-intercept. So basically what you have to do is solve for x. So I'd solve for x on both sides, and when I solve for x on both sides, I'd find out x equals 5 and x would equal negative 7. So those would be my intercepts where it would cross the x-axis. If you check out example 2 here, or example B, you would notice that A is not 1. When A is not 1, we had a different tactic to go ahead and factor this down into two binomials. What we did is we took the product of AC. So here's A times C. We came up with 18. The next thing that we did is we go ahead and we put down 2x squared, and we saw that this was minus plus, which would be minus something and minus something, and then we'd go ahead and say plus 9. Now, the AC product, remember, it has to have a product of AC, so what times what would give me 18, and I would again have that sum of B. 6 and 3, so we'd have a negative 6 and a negative 3. That would give me that negative 9, and remember we are talking x here, so don't forget to fill in that x value. What we did next is what we called factor by grouping. So we go ahead and group this first set here, and then I said plus a negative to show that that is a negative 3, and I factored by grouping. So basically what we had here is 2x squared minus 6x plus negative 3x plus 9. Out of that first group, what can we factor out? Well, we can factor out 2x. When I factor out 2x, I'm left with x minus 3. Now, we have to get to x minus 3 for a second set. So what can we factor out of the next group? That would be a negative 3. When we factor out the negative 3, we wind up with x minus 3. Remember, we want two binomials that have the same thing. Now we can go ahead and rewrite this. We'd say 2x minus 3 is one binomial, and the second binomial would be x minus 3. Now that you have two binomials, now what you need to do is set them equal to 0 to use that zero product property to find out your x-intercepts. I've set both binomials equal to 0. Now I could go ahead and solve for x in both of these problems. I have solved both problems, and again what we have found here is our x-intercepts, where the parabola, that U-shaped graph, would cross your x-axis, and that would be 3/2 and 3. Much like you did in example, or I should say lesson 38, another way that we found the x and y intercept was simply by looking at a graph. So I'd look at this graph and I would say that my x-intercept in this case, by looking at the graph, is going to be, or actually the x-intercept would be 2, and my y-intercept here, where it crosses the y-axis, would be -4. And again, by looking at a graph would be an approximation. So go ahead and example 2b, why don't you go ahead and find out your x and y intercept. Pause the video here and get those filled in. In B, hopefully you came up with something for an x-intercept of possibly -3 and -7, and that y-intercept being 7. Again, those would be estimates, but should be right around there. So again, to reinforce this concept, example 3 and 4 here, we're going to go ahead and, without graphing, we're going to find the x and y intercepts. So we've kind of have an idea of how to find the x-intercepts. You're using that zero product property. You're going to take those binomials or the things in factored form and go ahead and come up with binomials. This is in factored form because we don't have that x squared. So you're going to set them both equal to 0. So you have -x, I'll set it equal to 0, and I have x minus 3 and set it equal to 0. From here I can go ahead and find out my x-intercepts. So in this problem I divide by -1 on both sides, add 3 here, and over here we have x equals 0 and x equals 3. So those would be my x-intercepts, which would be 0 and 3. And remember, when you worked with linear functions, to find the y-intercept, you'd simply put in 0 for x. So every spot that I have x, I'm going to go ahead and throw 0 in for it and find my y-intercept. So I would have f of x equals negative, in for x would be 0, parenthesis, in for x is 0, minus 3. Follow my order of operations, take care of my parentheses. I'd have 0 minus 3, which would give me -3, and we'd have 0 times -3, and we'd find out that my y-intercept is going to be 0. Again, my last problem here, go ahead and find out my x and y intercepts. I look at the problem, I see that it is not in factored form. I see that my a value is 1, so again I'm going to go ahead and put this into factored form. Would be the first thing to find out my x-intercepts. I see it as minus plus is minus minus. So I'd say what has a product of C that would have a sum of B? Well, that's going to be 1 times 5. So then we'd have -1 and -5 giving me that -6. Simply set it equal to 0. Set both of these equal to 0, both binomials that is. Now I can go ahead and figure out my intercepts by solving the equations below. Add 1 to both sides, we have x equals 1. Add 5 to both sides, we have x equals 5. So those are my two x-intercepts for my parabola, 1 and 5. And now I need to find the y-intercept. To find that y-intercept, again, simply take the original equation. To find a y-intercept, you put in 0 for x. So I have 0 squared, and I have -6 times 0, and then I would have my plus 5. This would give me 0. -6 times 0 is 0. 0 and 0 plus 5, and you find out your intercept is y equals 5. So the y-intercept would be 5. This would conclude lesson 39.